Alright, good afternoon everyone. So this video will be short because it's just covering the two questions that that I wasn't able to teach because I wasn't here today. And there will be a separate video leading into our next topic, which will be the intersections of planes. So first, let's just go into this question. It's also written in your OneNote. I just wanted you to have the video so you kind of have me narrating over the step-by-step solution of each question. But find the distance from the origin to the plane that's through these 3 points. And we don't need we don't need 4 points to define a plane because I know whenever I draw a plane in class, it's always as a parallelogram. But remember, once I've got these 3 points, I can already kind of imagine where this last one is, right? Because this would be one of the direction vectors, so my D and the E of my plane. So you don't actually need all 4 points because the plane extends infinitely anyway. So it's not like that last point is going to do anything for you. So I'm given my 3 points, A, B, and C. And like I said, I need the D value, the E value, D and E vector, I should say. Of course, I need my normal, because I can only get my normal by having these two. So hypothetically, if I were to be able to get my normal without either one of these, then I'd be set. But I need to get these two in order to get the normal. And then of course I need the vector to like P1, P2, like part of our formula, to see where the distance starts and stops. So let's do that piece by piece. D is just going to be AB. This is just going to be AC. You can use any two combinations, right? You could do BC and BA. It's going to give you the same thing. All right. Well, I mean, your the values will look different, but you'll still get the same final answer because the distance between the point and the plane is still going to be the same. So, doing my calculation here, I've got 3, 2, minus 5. And for AC, I've got 5, 0, and negative 1. And now, in order to get my normal, I do the cross product. So, again, you can do it this way, or you can do, I know some of you enjoy the matrix method because it's less tedious to write out your vectors twice, but the only thing with the matrix method is to not forget to flip the value of your j, so your middle value. So crossing out these two columns, and then doing my cross. Okay? And this will spit out a value for my normal of negative 20, or sorry, negative 2, negative 22, and negative 10. Getting a little ahead of myself there. And I can just simplify this to make my life a little bit easier, getting rid of all the negatives and dividing everything by 2 to just give me 1, 11, and 5. Okay, and now that I have my normal, like I said, remember our distance formula is our absolute value of P1, P2, dotted with my normal, divided by a squared plus b squared plus c squared, all under one root. So I've got pretty much almost all my ingredients, right? I've got a, b, and c separately. I've got my normal as an entire vector, and now I just need p1, p2, and that's going to be my vector going from the origin to A. Okay. And that, again, nice and easy to calculate because our origin is just, well, 0, 0, 0, right? So it doesn't change the value of A. So it's just going to be 1, 0, and 4. And we plug this into our equation. D is equal to 1, 0, 4, dotted with 1, 11, and 5, divided by the square root of 1 squared plus 11 squared plus 5 squared. And because it doesn't specify to keep our answer as an exact value, I am going to get an answer of 21 divided by the square root of 147. But I don't need to bother rationalizing my denominator because I'm going to have to round to 3 significant figures anyway. So this is roughly equal to 1.73 units. Okay. Of course, if it said exact value, you would just multiply the top and bottom by the root of 147 to rationalize your denominator. But here we just let our calculator do the heavy lifting for us. Okay, so now our second question Nice and straightforward. Just find the angle between the two planes, and this time our planes have been given for us. So again, I hope you did this for the first question as well, but hit a quick pause, try the question on your own, and then hit play when you're ready to see the solution. Okay? So here, nice and easy. We don't have to find our normal because it's given to us just indirectly. So the normal of plane 1 and the normal of plane 2 is just going to be equal to here. It's going to be 2, -1, and 1, right? It's just my coefficients on my three variables, and 1, 3, and 2. And now that I have my two normals, I know it's really hard for me to kind of demonstrate it with a document camera, but if you look at the OneNote, remember that if these two, I know they just look like lines because I'm not using sheets of paper, but if these are my two planes that are intersecting, and let's say the angle between them is like this angle up here between the tip of my pen and my index finger, the reason why it works when I also use my normals is because remember, the normals are 90 degrees away, I was going to say, or off of the plane. But if I shift both, or in other words, if I use the normals for both planes, then I'm compensating for the offset of 90 degrees by using my normal here, by also using a normal here and creating another offset of 90. So it kind of looks like this. It's like, imagine if my sheets of paper were, let me just get a quick sticky note for you to have. Like, imagine my two planes were these two sticky notes. And just for simplicity's sake, I'm going to give you like a bird's eye view to make them almost look two-dimensional. So again, see that angle up there? If I get my normals, then it's essentially almost like rotating 90 degrees. So everything moves over 90, but the angle between the two sheets of paper never actually changes. So that's why we can use our normal. Okay. If that visual example was a little confusing, I don't blame you because it's a little bit of an improvisation on my part. So check out the OneNote. I kind of did a little diagram between the two planes and did a word explanation that might make it more clear. But now that I have these two, very nice and straightforward, the cosine of theta is just going to be equal to everything plugged in, right? I've got one normal dotted with my other normal divided by the magnitude of both individual normals. So 2 minus 1 and 1 dotted with 1, 3, and 2, then divided by the square root of 6 and the square root of 14. So this is just going to give us, what do I have here? 1 over the root of 6 root 14, because that's what our dot product gives us, is just 1, so it's nice and easy. And now we just do our inverse cosine, and it spits out and gives us a value of 83.7 degrees. And we are all set. Okay, so I hope this made sense. It's just two questions we didn't get a chance to finish in class, and I was going to teach yesterday, or sorry, today. The days are blurring together. Our next topic, like I said, will be a separate video, and it will be on the intersections of planes. Okay? I will see you on Thursday.